In this example, we want to write a set of equations from which we can find the voltage V, which is the voltage across this 10 ohm resistor with this given polarity. I'm going to do this using mesh analysis, and I'm going to use the given constraint and mesh loops that are provided on the circuit diagram. I only have one mesh loop, I1. So to do KVL around I1, starting down here and following the direction of the given mesh current, I see a negative terminal first on the 5-volt source. That's a minus 5 volts. Plus, now I'm going to assign my voltage polarities according to the direction of the current that I'm following. So this is going to be my positive terminal, and this is going to be my negative terminal. That means I'm going to be entering the positive terminal, which gives me a positive sign here. And then the voltage across the 20 ohm resistor is the resistance, 20 ohms, times the sum of all the currents going through that resistor. The only current going through that is I1. Now I come around here. I'm going to assign the voltage across this 10 ohm resistor according to the passive sign convention and the direction of my current. So this is going to be my positive and my negative terminals. I'm going to ignore, for now, this voltage V that I'm given. I'm just trying to find the current I1. After I've got the mesh current I1, I can find this voltage. So since I'm entering the positive terminal, I get a positive term. The voltage is 10 ohms times the sum of the currents through that resistor, which is I1, and this 18 amp constrained loop is also going in this direction over in this resistor, so that's a positive 18 amps. Then I come down here, going through the 15 ohm resistor. Again, I'm going to assign my voltage polarity according to the passive sign convention and the direction of the mesh current that I'm following. So this becomes a plus 15 ohms times I1. And again, the 18 amp constrained loop is also entering the positive voltage terminal, so that's a positive term. And this sums to 0. That's one equation in one unknown. So I can solve that for the mesh current I1. Once I've got the mesh current I1, I can find the voltage that I want, V. So my equation for the voltage, V. Now my mesh current is entering the negative voltage terminal. So V is equal to the resistance 10 ohms times the sum of the currents through that resistor. Since the mesh current is entering the negative terminal, that becomes a negative contribution. That's negative I1. The 18 amp constrained current is also entering the negative terminal, so that becomes a minus 18 amps. There are two equations in two unknowns. I can solve those for the voltage V. If you want to, you can retain this voltage V in your original mesh equation. It's unnecessary, and I recommend against it, but you can certainly do it. Now let's redo this KVL around I1. So starting down here again, I get a negative 5 volts. I'm going to use this polarity again. So this is 20 ohms times just I1. Now we're going to go through this 10 ohm resistor again. But I'm going to use this voltage V and its polarity. So now I enter a negative terminal, so that's a negative V contribution. Now down to my 15 ohm resistor, that's the resistance 15 ohms times I1 plus 18 amps. That sums to 0 because it brings me back to my starting point. Now I need an equation for V. V is still equal to the same thing it was before. It's the resistance 10 ohms times the sum of the currents through the resistances. I1 is still entering this negative terminal, so that's a minus I1, and the 18 amp source is still entering the negative terminal, minus 18 amps. That also constitutes two equations and two unknowns, and actually if you substitute this in here, you'll get this same equation you got up here. Now let's look at something that's kind of a common error, but I want to make sure that you avoid that. So some people do like to include this voltage V in their mesh equations. But if you do want to do that, make sure you don't make this mistake. So again, let's start down here and follow the mesh current I1. I see the negative terminal on the 5 volt source first. That's minus 5 volts. Plus, And I'll assign my voltage polarities across the 20 ohm resistor according to this sign convention. So that is entering a positive terminal. So this becomes a plus 20 ohms times I1. The 18 amp constrained loop doesn't go through the 20 ohm resistor. Now I'm going to enter this negative terminal. So, being a good student, I'm going to subtract that term off. Now I know that that is 10 ohms. That voltage is the resistance times the current. Now it's very common to just forget that I've used this as my negative terminal and say, now I want the sum of the currents through this resistor. That's I1 plus 18 amps. Then through my 15 ohm resistor, this is 15 ohms times also I1 plus 18 amps. That sums to 0. And if I do that, this term here is wrong. You're using an inconsistent sign convention. So the correct way to do this, yes, you do want to subtract this contribution if you're entering this negative voltage terminal. So that's a negative 10 ohms times the sum of the currents, but now the currents are entering this negative voltage terminal. So I1 enters the negative terminal according to Ohm's law. That has to be a negative I1, and the 18 amp source enters the negative terminal. So that's a minus 18 amps. Then these negatives all cancel out and it becomes 10 ohms times I1 plus 18 amps, which is the same result you would have gotten if you assumed that this is the positive terminal and this is the negative terminal. So if you're going to monkey around with your sign convention, make sure you're consistent with it. You should always end up with the same equations no matter what your sign convention is that you use.